Hi everyone, welcome to Impact Academy. I'm Yashasvi Chintada. Today let us continue with geography. Let us look at interior of the earth. Okay. So given below are the two statements. One is assertion and reason. Okay. So what is the assertion? The process in which one plate slides beneath another plate is called zone of convergence. Okay. And the seafloor spreading becomes more prominent along the zone of convergence. So if you look at plate tectonics, so there is one thing called intertropical convergence zone. Okay, ITCZ, uh, which will be see this region. Okay, at the 0 degrees, this is called ITCZ. If you just look at zone of convergence. Okay, the intertropical zone of convergence, which is near the equator. Two tecton that is ITCZ. Now, if you are looking at convergence zone, okay, they are discussing the region where two tectonic plates are colliding with one plate sliding beneath the other. The result is geological turbulence, fault zones that produce earthquakes, etc. etc. So basically, two tectonic plates are colliding with one plate sliding beneath each other. That is called as convergence zone. Okay. So the process in which one plate slides beneath another is called zone of convergence, which is true. So sea floor spreading becomes more prominent along the zone of convergence. So this is also true, right? Seafloor spreading. So seafloor spreading occurs at divergent plate boundaries. As tectonic plates slowly move away from each other, heat from the mantle's convection current makes the crust more plastic and less dense. The less dense material rises, often forming a mountain or elevated area on the seafloor. Okay, so you can see from the picture here also. So in this particular place, the process in which one plate slides beneath another plate is called convergence zone. That intertropical zone of convergence is different. So there is slight confusion with the name, but if you are talking about the convergent zone, then this is true. And sea floor spreading becomes more prominent along the zone of convergence, which is correct. So I would say the option is 3. Both A and don't go with this option. Both A and R are true, and R is the there is okay C. Fine. Actually, there is no proper option here, but anyway, just remember that both A and R are true. Okay, okay, maybe yeah, both A and R are true, but R is not the correct explanation of A. Even that is also fine. Okay, R is not the correct explanation of A, but both A and R are true. So 3 would be the option. So match the following elements, minerals, found in different parts of the earth. So we are talking about core, crust, mantle, and inner core. So if you look at this, so what is the question is asking about? What elements are found? So observe this. Inner core, okay, in the crust. So in the crust, what is there? Cl. Cl means silicon and aluminium. And in the upper mantle and lower mantle, there is Sema. Sema means silicon and magnesia. Okay, and in the core region, you have NiFe, that is nickel, and Fe means iron, ferrous, right? So, and also observe this, the crust, and upper part of mantle together form the lithosphere. Okay, very important. The crust and the upper part of the mantle. The crust and the upper part of the mantle form the lithosphere. And the crust, when we say, we are talking about one is the continental crust. Okay, continental the crust is which we are on which we are living. Okay, the land on which we are living, and the oceanic crust is below the ocean. This is the ocean. Below the ocean is the oceanic crust. So the continental crust has Cia. And if you are talking about the oceanic crust and the upper part of the mantle, then it is having Sima. And the innermost core is having knife, nickel and iron. So see Sial Sima, right? Sial is in uppermost, which is the crust. So 1B. So 1B. And we are talking about core and inner core. Okay. So we saw that mantle is having magnesium. So 2C. Is it 2C? So you already eliminated the other options. Obviously 3 is A. Is the core. Nickel and the innermost core is full of iron. Okay. So try to remember all these things. The upper crust is having Cl. Okay. Silicon and aluminium. And the upper oceanic crust and the upper mantle is having SEMA. Basically, the mantle is having silicon and magnesium. The outer core is having more of nickel, and the innermost core is full of iron. Okay, fine. So this is the option 3. 1B, aluminium is in the crust, and magnesium is in the mantle, and 3A, nickel is in the core, and in the inner core it is iron. Okay. Let us go to third question. With reference to the constituents of Earth's crust, which one of the following is correct? So just now we have done. So the continental crust is formed by basaltic rocks, not Sima. It is Sial. Okay, the continental crust is Sial. So this is wrong. The oceanic crust are formed by granitic rocks comprising Sima, not Sial. Sial is lighter than Sima because aluminum is lighter than other things, right? So Sial is lighter than Sima. So see, by studying this particular diagram, we are able to answer the question easily. So these are all very important. So only option C is the correct thing. These both are wrong. So first comes Cl, next comes Sima, then comes knife. So which of the following constitutes indirect sources of information about the interior of the Earth? So he's talking about the indirect sources. So volcanic eruption is a direct source because it is coming from within the magma inside. The core is coming out. So we can know what is in the interior of the earth directly. On the other hand, meteorite is coming from outside. So it is an indirect source. When the earth was formed, it was formed because many meteorites and all this dust, asteroids, everything came together, right? So even a meteorite shows us, I mean, what could possibly be inside the earth. So it's an indirect way. And also seismic waves. Okay, seismic waves. What happens is when you send different types of waves, especially if you look at earthquake and etc. What happens is only the S waves pass through solid only. Okay, the L waves pass through both solid and liquid. Okay, so they are very important. S waves, P waves, L waves. Okay, all those things. So S waves will pass through solid only. Okay, while the P waves will pass through solid and liquid. Is it? Just let us just quickly cross check. S waves, P waves. See, P waves can travel through liquid and solids. Yes, that's what I told. While S wave travel through only solids. So what happens is when they are sending the waves are getting deflected here. Okay, the waves are getting deflected. So they with that they are able to they are able to identify that the inside of the earth contains a combination of the innermost is solid, then the mantle, upper mantle is liquid, okay, and then you have solid. So they were able to identify all that because of these P waves and the S waves. Okay, and remember this very important: S waves travel only through solids, P waves can travel through liquid and solids and gases. Okay, all that is very important. So because of those waves, seismic waves also, we are able to get some information about the interior of the earth. So both B and C is the answer. They are called the indirect sources. Volcanic eruption, okay, deep mining, drilling, all those things are direct sources of information about the interior of the earth. Very important. So the dash is responsible for Earth's magnetic field, the outer core. Okay, the outer core. This is the outer core, and it contains lot of nickel. Okay, remember, the inner core is full of iron. The outer core also contains iron and nickel, and it is responsible majorly for the Earth's magnetic field, the outer core. So India is divided into how many earthquake zones? Okay, so this is frequently asked question. So even it was asked many times in regards of Andhra also. So how many earthquake zones does Andhra Pradesh have? Okay, how many? There are basically four zones. Okay, so this is frequently asked seismic zones. So we have four seismic zones: Zone 2, Zone 3, Zone 4, and Zone 5. Remember, there is no Zone 1. Okay, don't get confused. So if you look at Andhra Pradesh, you can see that there is Zone 2 and Zone 3. Okay, and Zone 5 is the highest. Zone 2 is the least active, seismic active. So there will be less earthquakes. That's why if you observe in Andhra, we don't get much earthquakes. But if you observe in Gujarat, okay, the Bhuj earthquake, all these earthquakes, and parts of the Himalayas, okay, in Himachal Pradesh, all these are, and northeastern region, they are highly prone to earthquakes. So there are four zones: Zone 2, 3, 4, and 5. Zone 2 is the least active, moderate, high, and highest. And now you also know least actives are most of peninsular India and parts of Rajasthan, Madhya Pradesh. These are all least active. Okay, so parts of Himalayas and what is this? Northeastern states and part of Gujarat is very high active, highly seismically active. So India is divided into how many earthquake zones? Four. Very important. So how temperature varies towards the center from the Earth's surface. So everyone is aware, right? Inside the core is very hot, right? It's molten magma and all is comes from inside. So the temperature increases as you go towards the center of the Earth. The Pacific Ring of Fire is associated with volcanoes and earthquakes. Okay, if you look at the world map, throughout the Pacific region, there is what is called as the Pacific Ring of Fire. Okay, very frequently asked Pacific Ring of Fire. Okay, so if you observe here, throughout the Pacific Ocean, you have a layer where it is full of all active volcanoes. So it is called the Pacific Ring of Fire. Okay, it is associated with volcanoes and earthquakes. It is inside the Pacific Ocean. So the most abundant metal in the Earth crust is Earth crust. Most abundant metal in the Earth's crust. Remember those things because it keeps changing. I mean, the crust has oxygen. Okay, see the composition of the Earth's crust. Okay, so if you are talking about crust, then oxygen is the highest. Okay, oxygen is the highest, 47%. And among the metals, iron and aluminium, aluminium is the highest. But if you are looking at the composition of Earth as a whole, then iron is the highest. So don't get confused. When you are talking about crust, aluminium is more than iron. Aluminium comes first. When you are talking about entire Earth, iron comes most, and aluminium is nowhere near to be seen also. Okay, so deep inside the earth is completely iron, 45%, and even oxygen comes second highest. So most people may not be aware of this, but in the earth's crust, the highest element is oxygen. So you can get easily confused unless you read it. Okay, so remember, earth's crust number one is oxygen, followed by silicon, aluminum, iron. Total earth, if you take, it is iron 45%, oxygen 30, silicon 15, magnesium, and nickel. Okay, and if you are looking by oxides, then silica oxide, alumina, and then comes iron ore. Even then also aluminum comes first in the Earth's crust. So that is if you're talking about the crust. So remember. So the most abundant metal in the Earth crust is aluminum. In the crust, if you're talking about whole Earth, then it will become iron. So which is the second most abundant metal in the Earth's crust? Obviously, iron. We are talking about crust. So first is aluminum, and we are talking about metals. So second is iron. If you are talking about element as a whole, then oxygen. Very, very important. Oxygen followed by silicon. Okay, only then comes aluminum. Silicon is, it comes from sand, right?